Okay, let's look at simplifying surds. So we need to simplify the square root of 18. So if we look at this, what we ought to be doing here is recognizing that 18 in this case is an even number, so we know it's a multiple of 2. So we've got 2 times 9. So we know that 18 is 2 times 9. Now, this looks a bit awkward with the square root over the 2 times 9. So sometimes the better way of writing this is actually separating this. So you've got square root of 2 times the square root of 9, and that is the same as saying the square root of 2 times 9. Well, the square root of 9 is 3. So what you've now got is the square root of 2 multiplied by 3. So we have now simplified this. All we need to do is neaten this up a little bit. So think about your algebra. We're going to get rid of the multiplication sign here. 3 root 2. And that is our simplified version of the square root of 18. If you put that in your calculator, that's the answer you'll come out with. Let's have a look at the square root of 27. Well, square root of 27 is 3 times 9, very similar to above. So in this case, the root of 3 multiplied by the root of 9. Again, we have now got root 3 multiplied by 3, which gives us 3 root 3. And that's simplifying our surds. Square root of 24. Well, I'm going to look for a pair of numbers, so you can look at your factors. You might go 1 and 24, 2 and 12, 3 and 8, 4 and 6. What I'm looking for, this is the crux of it really. What I'm actually looking for is a square number. So I can see that I've got a square number here. And the reason why I'm looking for a square number in my factors is I want to be able to square root that number. So I'm not going to use these ones here. I'm going to use the 4 and the 6. So now square root of 24 is 4 multiplied by 6. Square root of 4 times square root of 6 is 2 root 6. And that is simplifying surds. Okay, let's look at 2 more examples. Let's simplify the square root of 50. Really, we're looking for factors of 50, but in those factors, we are looking for a square number. Now, I'm going to stop there because straight away I can recognize that 25 is a square number. I could carry on and get 5 and 10, but there's no point in me putting the 5 and 10 because already I've got myself a square number. That's what I'm looking for. So I stop at this point. I don't need that. So I know the square root of 50 is the same as square root of 2 times 25. Well, I can't root the 2, so it remains as the 2, but the square root of 25 is 5. All I need to do now is rewrite that as 5 root 2, and that is simplified. Let's look at this example here. Square root of 35. So 1 times 35, not even, so 2 isn't a factor. 5, 6, 7, 8. Adding those 2 digits together gives me 8. 8 is not a multiple of 3, therefore it's not divisible by 3. 4 is not a factor because it's not even. 5 is a factor because it ends in a 5. So in this case, we've got 5 times 7. 6 is even, so there's no more factors of 35. So you'll notice none of these numbers are square numbers. We cannot square root any of these. So actually, that is already a surd. We cannot simplify it any further. So you can't always take them down further. In this case, that is as simplified as it goes. Okay, last couple of points. If we look at these two here, the square root of 108, I want to show you there's more than one way of doing this. We could use the method we were using a minute ago just by finding factors, so 1 and 108. Really, if you think about it, there's no point in doing this because you're already at 108. Okay, so I'm going to go straight into 2 and 54 and 3 and 36, and there are more, but I don't need to go any further because I have found my square number. So if I write this out, we have got the square root of 3 multiplied by the square root of 36. Square root of 36 is 6 multiplied by square root of 3, which remains as 3. So we just put root 3. There's our answer. Some people will recognise that is the same as saying 9 multiplied by 12. 12 nines are 108. Well, you've got your square number there, okay, which is 3. So the square root of 9 is 3. The 12 we can take further, and we should take it further. We break it down to its component parts. So actually 12 is the same as saying 3 times 4. Now notice we have now gained another square number. So we've got two square numbers here. So this is the same as saying square root of 9 multiplied by the square root of 3 multiplied by the square root of 4. Square root of 9 is 3, root 3 remains, square root of 4 is 2. 2 times 3 is 6, and you're left with exactly the same answer, 6 root 3. So the point of showing this is that some people have a different way through to get the answer, but the key thing is you keep breaking these numbers down until you can't go any further. Finally, I want to look at just clarifying one thing. When we talk about roots of something, so normally let's not talk about surds, let's talk about the square root of 9. Well, the square root of 9 has two answers. It has a positive 3 and it has a negative 3. Now, when we are dealing with surds, we are only dealing with the positive. Let's get to that one there. In this case here, that is a positive only. So remember, with surds, you're dealing with a positive root only, not a positive and negative root. So now you can simplify surds. Let's see if you can actually use them in calculations. Have a look at the next video.